In this video, we're going to take a look at linear programming problems. And in my first example, I have a company manufactures two types of electric hedge trimmers, one of which is cordless. The cord type trimmer requires 2 hours to make. The cordless model requires 4 hours to make. The company only has 800 hours to use in manufacturing each day, and the packaging department can package only 300 trimmers per day. If the company sells the cord type model for $22.50 and the cordless model for $45, how many of each type should it produce per day to maximize its sales? So here we're going to need some inequalities to set up our restrictions as far as, in this problem, hours they have to manufacture and how many can be packaged per day. And we need a function that will represent the sales. So for our inequalities, we want to take a look at how many hours they have for each. So we can see the cord trimmer takes 2 hours and the cordless model takes 4 hours, and they have 800 hours available. First thing we're going to do is set a variable for each type of trimmer. So we have X is the cord type and Y is the cordless. So now to set up our inequality for hours of manufacture, we know that it takes 2 hours to make a cord trimmer and it takes 4 hours to make a cordless trimmer, and we know that we have 800 total hours available. And if 800 is the max, we're going to have a less than or equal to sign in between. So this is our manufacturing hours, and now we need to create our packaging hour restriction. So if we have 300 hours to package the total amount of trimmers, we have X plus Y has to be less than or equal to 300, which is the max. And now to set up our sales function, we know that the cord type trimmer sells for $22.50 and the cordless model sells for $45. So we're going to say that sales is equal to 22.50, 22.5 times the cord trimmers plus 45 times the cordless. So now the first thing we want to do is graph our inequalities. So with this first inequality, if we put 0 in for X, we would have 4Y is equal to 800, so Y would be 200. So we know 0, 200 is our y-intercept. And then if we put 0 in for y, we would get 400 for x. So we know that 400, 0 is the x-intercept. And now we need to draw a straight line connecting that. And now that we have a straight line connecting it, we can graph our other inequality. And here, if x is 0, then y is 300. And if y is 0, x is 300. And again, we need to draw a straight line. So now that we have both inequalities drawn, we also have to remember that in application problems, we're only going to deal with quadrant 1. We're never going to have negative hours worked in manufacturing, and we're never going to have negative trimmers packed per day. So we don't have to worry about quadrant 2, 3, or 4. So that means our bounded region for this problem is in here. So now we need to take a look at the corner points. So we have 0, 200, where these two lines intersect, at 300, 0. So we could write these in. We need to find that value. We have 300, 0, and then we're also going to check 0, 0. And now in order to find where these two lines intersect, we're going to rewrite our two inequalities and solve for y and set them equal to each other. So I have 2x plus 4y is equal to 800, and we have 4y is equal to 800 minus 2x, and y is equal to 200 minus 1/2 x. And then we also have x plus y is equal to 300. So y is equal to 300 minus x. And now if we set the two equal to each other, we find where they intersect. So I'm going to add x to both sides and subtract 200 from both sides. So I have 1/2 x is equal to 100 and x is equal to 200. So in order to find y, we're going to say y is equal to 300 minus 200, or y is equal to 100. So we know that this intersection point now is 200 and 100. So now in order to find which one maximizes our sales, we're going to use our sales function, 22.5x plus 45y, and then we're going to get our amount, and we're going to test each of the corner points. So we're going to test 0, 0, we're going to test 0, 200, we're going to test 200, 100, and we're going to test 300, 0. And when we plug 0 and 0 in, we get 0. 0 and 200 gives us 9,000. 200 and 100 gives us 9,000. And 300 and 0 gives us 6,750. So we actually have two places that will maximize the sales. We have 0, 200 and 200 and 100. And if we look back at our initial problem, it's asking us how many of each type should we produce to maximize its sales. So we can either produce 0 chord types and 200 chordless, or we can produce 200 chord types and 100 chordless to maximize sales. And that's how we analyze a linear programming problem.